In the last video, we have successfully routed and completed the PCB. In this video, we'll see how we can verify the design with KiCad's design rule check and also add some branding elements along with various graphics to the printed circuit board. If you remember from one of our previous videos, we performed ERC to check for errors and mistakes in schematics with the help of KiCad's predefined rules. Similarly, here in the layout editor, there are certain set of predefined rules along with the custom constraints that we set. Using this, we can perform DRC, design rule check, to see if our board design is within this set of rules. Now let's see how to perform DRC within PCB layout editor. Go to the top toolbar and click on Design Rule Checker. For now, we'll keep all the settings to its default and just click on Run DRC. Seems like we have no errors, but 3 warnings. Just for the sake of the video, I'll introduce few errors so I can show you how to fix them. So now let's run the DRC again. Now you can see we have 14 warnings and 4 errors. For now, we'll just focus on errors and we'll come back to warnings later on. So I'll just uncheck the warnings. The first error we have, courtyards overlap. Let's click on the error and see where it takes us. Here we can see the courtyard of 2 components overlapping each other. But how will this affect the PCB? So let's quickly see the same layout in the 3D viewer. On 3D view, we'll have a better understanding of what's happening. And if you carefully observe here, these 2 components are overlapping each other. This could cause some serious assembly issues if this particular PCB is sent for manufacturing. So always make sure you perform DRC before you send the files to manufacturing. Luckily, these are easy errors to fix. All you have to do is just make sure we have proper clearance between the components. Also try to keep the components without overlapping each other's courtyard. Now let's run the DRC again. You can see the previous error is gone, but we still have 2 more errors to solve. To see the other 2 errors, click on the Unconnected Items tab. This tab will show all the unconnected nets between the components. Since our circuit was very simple, I had to manually delete a few connections to force this error. But if you are working on a complex circuit with hundreds of connections, this particular DRC check will come very handy to find the missing connection. Now to see where the net is unconnected, just click on the error. It will take us to the location where the nets are unconnected on the PCB layout. And here you can see the arrows are making it very obvious that these 2 connections are unconnected. So I'll quickly use the route tool and make the connection between these 2 points. Now if I run the DRC again, we can see the previous error was solved. To find the next unconnected net, I'll just click on the connection again. And I'll quickly do this connection using the route tool. Now if I run the DRC again, you can see all the errors are resolved. Similarly, we can try to resolve all the warnings. So I'll check the warnings again and go to violations. We have 3 warnings, but it's less likely to affect the functionality of the PCB. So in some cases, it's okay to ignore these warnings and send the file for manufacturing. But it's always good to clear up all the warnings because these warnings can quickly turn up into errors when you work on the same PCB to improve the circuit or work on updating the features. Currently, the first 2 warnings are just telling us that KiCad cannot find the footprints that we are using from footprint library. But we know that that's not the case because we did use all the default footprints given by KiCad. These warnings can occur when KiCad's library is not in sync with the footprint used on the PCB editor. We can quickly fix this by right-clicking on the footprint and click on Update Footprint. And on this window, make sure Update Selected Footprint and then click on Update. And now if I close this and run the DRC again, you can see the number of warnings has decreased to 2. Now the next warning is very similar to the first one. So I'll just click on that, then select the footprint, right click and click on Update Footprint. And here I'm making sure Update Selected Footprint is selected and then hit on Update. Now once you go to the 3D viewer, you can see the cell holder and the switch is gone. That's because while updating the footprint, we lost the reference to the 3D model's location. But adding them back again will cause the same warning. Since anyway we are at the end of the PCB development and we won't be needing these references anymore, we can just turn off the 3D model and work with the PCB. Finally, we have one warning left. This warning is because of the constraint we set on the board setup using the manufacturing capability limit, according to which the silkscreen item should have a clearance of 0.15 mm. But if I click on the warning, we can clearly see that's not the case. So I'll just move this slightly away from the footprint and then run the DRC again. You can see we have cleared up all the errors and warnings. Now the PCB design is perfect for manufacturing, and also it follows all the constraints that the fabrication plant needs. Personally, I do miss having graphics and branding elements on the PCB. So I'll show you how we can add a logo or custom graphics to the PCB. Go to the KiCad's project window, then click on Image Converter. This window will help us convert the logo or image into a footprint that can be placed on the printed circuit board. To load up the graphics to the image converter, click on Load Source Image. And here, select the logo that you want to source. Here the current size of the logo is 158 mm, which is way too large to fit within our PCB. In this case, we can reduce the size of the logo to a lower value that can fit within the PCB. I'll just enter 5 mm. Now in this particular tab, it feels like there's nothing happening. To see the output, go to Black and White Picture tab. Since we have only one color on the silk layer, KiCad will convert the image to black and white, and we can adjust the output using this slider. In this output, the black part of the image will be applied with silk screen and the white part will be ignored. And if you like to invert it, you can just click on this negative checkbox. In our case, I'll just keep it to positive, so I'll just uncheck the negative and adjust the slider. And next, go to board layer for outline, select front silk screen, go to the output format and click on footprint. Now we can move this customized image to the board editor in two ways. Either we can save the image using export to file and use the image in all other projects, or we can just copy the image to clipboard and paste it on the PCB editor. I'll go with the second option. Copy the image using export to clipboard and go to the PCB editor, and before pressing Ctrl V or paste, make sure you select the front silk screen and then hit Ctrl V and select the location where you want to place the logo and then just do a left click. Now you can see there is excess text along with the logo. We can easily get rid of this. Just select the logo and click the letter E. Now under the reference designator, uncheck the show option. Then hit OK. Now let me try to add a text along with this. So I'll use the text tool and enter a text. Also, I'll slightly change the appearance to my personal preference. This looks pretty good now. We can add more graphics using the different tools that's available on KiCad. Let me show an example using the rectangle tool. I'll select the rectangle tool and making sure I'm on the front silk screen layer, then draw a rectangle around the logo. So far we were working on the front silk layer, but we have a lot of empty space on the bottom that we can fill up with details about the PCB or more information that we like to add. I'll just go back to the PCB editor, make sure back silk screen is selected. Let's add some open source and precautionary logos. So those are already inbuilt within KiCad. So we can just go to the add footprint tool. And under this, you can see various logo. For this example, I'll use designed with KiCad. Select this and place over here. You can see the footprint was placed automatically to the front silk screen, even though the option was selected to the bottom. In this case, we can just select the logo and then just do a right click and click on change side or flip. And now if you go back to the back silk screen, and you can see the logo has been placed on the back of the PCB. That looks pretty good. So let me add few more logos. This circuit is pretty much ready for manufacturing. We can't just send the KiCad file to the fabrication plant. This not only makes the process a little difficult for the manufacturers to convert these files, but also if this was a private design, you'll be giving up your intellectual property, where people can use the project file to edit the project, and also they'll have all the information about the circuit. So in the next video, we'll see how we can export this KiCad project into a Gerber file which is widely accepted by all the manufacturers around the world. Until then, if you have any questions or doubt, you can always reach out to us at PCB Cupid Q&A. Make sure to like and subscribe to the video so that we can keep making such amazing content. If you think the content is worth sharing, share it with a friend who might have interest in this topic. Until then, keep learning and keep creating.